These are the day 6 notes for our statistics unit. Today we're going to be talking about something called summation notation, also known as sigma notation. You'll notice that in the problems that we're looking at below here, there's this strange symbol here, which is actually a letter of the Greek alphabet known as sigma. It kind of looks like a goofy looking E. And in Greek, the Greek letter sigma is used to show repeated addition in mathematics. So this is a way of saying we're going to be adding a bunch of things together. So think sigma, sum. We're adding numbers together. Sigma, summation, starts with the same letter at least. So in this notation that we see here, we have this Greek letter, which means we're going to be adding a bunch of things together. There's this letter I, and the I in this problem stands for the index. This is the value that you see kind of on the right side, and it's also underneath. So let's talk about this underneath value first. Underneath here, it says something like I equals 1, or I equals 5, or I equals 0. I is going to tell you the starting value. So we're going to be starting at 1. More on this in a little bit. The number at the top, the number above our Greek letter sigma, tells you where we're going to be ending at. So the number on the bottom tells us we're starting at 1 and we're going to work our way up to 6. Or we're starting at 5 and we're going to work our way up to 9. The expression that's to the right of sigma, so we have something below, which is what we're starting with, something on the top, which is what we're ending with. The value on the right side is an expression. And this is the formula that we're going to be substituting all integers between the starting and ending values into. So sometimes the formula is going to be something simple like I, sometimes it'll say 2I, or sometimes it'll be even a more complicated formula. This is a formula we're going to be plugging numbers into, and then we're going to end up adding some things together. Also, in these examples, just want to make sure it's clear, we have used I to represent the square root of -1 in the past. In these examples, I does not represent that. I is just standing for an index or a formula. So how exactly does this work out? Let's take a look at our first example. In our first example, the number below the sigma notation is where we're starting at. So we're going to be starting at 1, and the number at the top is what we're ending at, so we're going to end at 6. This is our formula. So our formula says we're just going to plug in the number 1 in place of the I. So we're going to start by plugging 1 in for this I. 1. And then we're going to go up by 1s until we get up to the number 6. So I'm going to plug in 1 for I get 1. I'm going to plug in 2 for I, we get 2. I'm going to plug in 3 for I, we get 3. I'm going to plug in 4, and then 5. And then once we get to 6, that's where we're going to end. So it's sort of like I'm plugging a bunch of numbers into this formula. I plugged in 1, 2, 3, 4, 5, 6. And then whatever you get, sometimes it's just these numbers, but whatever you end up with, we're going to end up adding these values together. So if you end up adding the numbers 1 and 2 and 3 and 4 and 5 and 6 together, you could probably do this in your head as well. You get 21, and that's your answer to this question. So this notation is a shorthand way of saying add 1, 2, 3, 4, 5, and 6 together. The second example is very similar, except we're going to start by plugging in 5. So the number at the bottom is what we start with. I'm going to plug in 5 for I, and I get 5. And then I'm going to go up by 1s until I get up to the number 9, and I'm going to stop. So I'm going to do 5, 6, 7, 8, 9, stop at 9, and then we'll add these numbers together. So this is a simpler way of saying add 5, 6, 7, 8, 9. Maybe to you it doesn't seem simpler, but it requires less writing than writing this out. So you can imagine if the problem said like I equals 50 to 90, that would be a lot quicker than writing 50 plus 51 plus 52 plus 53. So a lot of times in math class we have these goofy symbols or different notation to actually save us time in writing things out. When you add these numbers together, you get 35. Now our last example is a little different. There's still a starting and an ending value, but this time it says 2I. So what we're going to do is we're going to substitute this bottom number 0 into this little expression. So I'm going to replace the I with a 0. It's not going to make it 20. This is 2 times I. So this is going to be 2 times 0. And then I'm going to go up by ones until I get to number 3. So I'm going to plug in 1 for I, 2 times 1. Plug in 2 for I, 2 times 2. Last number I'm going to plug in is 3. That's where we'll stop. 2 times 3. So whatever this expression is, we're going to plug in every number between this one and this one. So I'm going to plug in 0, 1, 2, and 3. And we're going to go 2 times 0, 2 times 1, 2 times 3. You could type it in just like this on your calculator. If you want to simplify matters, you could do the 4 multiplications. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and then add the numbers this way. So that's one way that you encounter this new notation, which is called summation notation. There's another similar type of process which involves adding numbers in a data set together. So if you want to add numbers in a data set together, what we'll do is we're going to call the first value in the data set x sub 1, like x subscript 1. The second value in the data set we'll call x sub 2. The third value x sub 3, etc. This expression, we have a 5 on the top, I equals 1 on the bottom, x sub I as your little expression, means what we're going to do is we're going to sum the values starting at x sub 1, plug in 1 for x, or 1 for I, excuse me, and we're going to end at x sub 5. The expression you see here means plug in 7 for x, we have x sub 7, end at x sub 10, and add all the values starting at x sub 7 to x sub 10 together. In other words, this is kind of what we're talking about. So imagine you have a list of numbers. Let's say these numbers are 2, -5, 10, 4, 12, and 1. If we write these with our subscript notation, we're going to say that x sub 1 is 2. So we're going to call this first value x sub 1. The second value is called x sub 2. Third value, fourth value, fifth value, sixth value. When you see this notation means plug in 1 for the I. So we have an x with a subscript of 1. And then we're going to plug in a 2 for the subscript, a 3, a 4, so on and so forth until we get all the way up to x sub 6. And we're going to add these values together. So this means add the first, second, third, fourth, fifth, and sixth values in our list together, which we said are 2, -5, 10, 4, 12, and 1. So we're going to replace these numbers with 2, -5, 10, 4, 12, and 1. We're just adding the first through sixth numbers in your list. When you add these numbers together, again, if you want to do these mentally, you probably could. If you want to use your calculator, we're just going to go 2 plus -5 plus 10 plus 4 plus 12 plus 1. And when you add these numbers together, you get your solution. Pretty reasonable to crunch this out. I got 24 for my answer. In the second example, we have 3 as our starting value, so we'll plug in 3 for your subscript, x sub 3. The next number is going to be 4. And the top number says stop at 5. So we're going to add the third, fourth, and fifth numbers in your list together. So x sub 3 is the number 10. X sub 4 is the number 4. X sub 5 is the number 12. We're going to be adding the third, fourth, and fifth numbers in your list together, which are 10, 4, and 12. And when you add these together, 10 plus 4 is 14. 14 plus 12 is 26. All right, so some trickier problems next. I equals 2 to 5. So the first thing we're going to do is we're going to replace the I in this problem. It says 2x, or 2 times xi. We'll replace the I with the number 2. Then we're going to rewrite the same expression, but we're going to replace this I with a 3. And we're going to do this until we get to 5. That's the last number on our top of our sigma. And then we're going to add these together. Sigma means whatever you get for these values, add them together when you're done. So we're going to take 2 times the second number in your list, x2, which is -5. we're going to do 2 times x3, which is the third number in your list, which is 10. 2 times the fourth number in the list, which is 4. And 2 times the fifth number in the list, which is 12. If you want to crunch these out kind of separately, you'll get negative 10, 20, 8, and 24. When you add these together, negative 10 plus 20 is 10, plus 8 is 18. 18 plus 24, if you need to crunch that out, is equal to 42. And that is what your sum should equal. What about this stuff? Again, replace the i's with the bottom number that you see in this index. So if it says I equals 1, replace both of these i's with a 1. So we have is x sub 1 squared plus 2 times x sub 1. Then replace the i's with 2's. X sub 2 squared plus 2 times x sub 2. And then we're going to do a 3, that's the last number, x sub 3, replace the I with a 3, squared plus 2 times x sub 3. When we're done, we're going to add these 3 sets of values together. This, plus this, plus this. If you want to put these things in parentheses, you could do that as well. That's okay. Now we're going to substitute. X sub 1 was equal to 2. So this is going to be 2 squared plus 2 times 2. X sub 1 is 2. X sub 2 is negative 5. Whenever we do substitution with negatives, I think it's smart to put the negative in parentheses. So we have negative 5 squared plus 2 times x2, which is again still negative 5. Plus x sub 3 is 10, so this is going to be 10 squared plus 2 times 10. You could type all this in your calculator. If there's mental math that you can handle, I think sometimes that's a little bit of a shortcut. So 2 squared is 4 plus 2 times 2, which is 4. Negative 5 squared is 25. It's positive. Plus 2 times negative 5 is a negative 10, so I'm going to write minus 10. Plus 10 squared, which is 100. Plus 2 times 10, which is 20. So 4 plus 4 is 8. 8 plus 25 is 33. 33 minus 10 is 23. 23 plus 100 is 123. Plus 20 is 143. And that's your answer here. All right, last one. Replace the i's with the bottom number. In this case, it's 1. So this will be 1 plus x sub 1. Replace, now we're going to move up. These are 2's now. 2 plus x sub 2. Last number is 3. 3 plus x sub 3. So this is kind of using a combination of what we learned at the top with what we've done on the bottom. So 1 plus x sub 1 is the first term, which is 2, plus the number 2 plus the second term, which is negative 5, plus 3 plus the third term, which is 10. I've done the mental math before. If you'd rather just type it in your calculator, that's probably not too hard. Just make sure that you put that negative 5 in parentheses. And when you add these numbers together, you get your answer for the last question, which ends up being 13. So this is how you work with summation notation. Really not too hard. It's just a matter of plugging the bottom number in for the I, and then just increasing that number until you get to the top value, and then adding these different values together.